Many histories of the Korean War focus on battles, troop movements, or diplomatic stalemates, but one of the most persistent, overlooked challenges was far more mundane: the construction of field structures using timber and simple joinery. What most people don't realize is that countless posts, depots, and shelters fail not because of enemy action, but because of a fundamental mistake in structural practice that modern builders still repeat. Old carpenters, whether in Korea, Europe, or North America, knew methods to make wooden structures endure decades, even under harsh environmental conditions. By ignoring these principles, engineers during the Korean War inadvertently compromised both soldier safety and operational efficiency. If you are serious about understanding the war beyond headlines, and about learning lessons that apply to both historical analysis and practical survival, subscribe to the channel. These are the types of insights that reveal why certain decisions mattered far more than surface-level tactics. The Korean climate exposed every weakness in construction. The peninsula's environment is deceptively harsh. Summers are hot and humid, winters are bitterly cold, and rainfall is both frequent and intense. Soldiers and engineers were tasked with erecting barracks, observation posts, and storage facilities quickly. Timber was plentiful, but the urgency of construction often outweighed considerations of durability. Engineers often relied on nails, screws, and simplistic framing techniques, assuming that short-term functionality was sufficient. What they did not account for was how moisture, temperature shifts, and frost cycles interact with wood over time. Pine and fir, widely used for their availability, expand, contract, warp, and crack when exposed to repeated wetting and drying. Floors sagged, roofs shifted, and entire outposts became unsafe within a single season. Soldiers had to spend hours shoring up weakened structures, diverting manpower from critical tasks. The mistake was ignoring joinery techniques that have worked for centuries. You see, modern construction often favors speed and standardized fasteners, but historical carpentry relied on precise joinery to distribute stress and extend longevity. Mortise and tenon joints, scarf joints, and dovetails transfer load across the timber itself, rather than relying solely on nails or screws. Korean War-era engineers sometimes used these methods, but, often abandoned them because they were time-consuming or required skill that new draftees just lacked. Field manuals from the era rarely emphasized joinery, focusing instead on quick assembly. The result was structures that could collapse under snow loads or fail during heavy wind. In contrast, older carpenters built barns, homes, and fortifications that survived decades, sometimes centuries, without modern fasteners. This contrast highlights a practical lesson. The strength of a structure often depends on how forces move through its materials, not just the raw strength of individual elements. Structural failures directly affected survival and operational capability. When wooden shelters failed, the consequences were immediate. Frostbite, illness, and fatigue increased because soldiers were exposed to wind, rain, or cold floors. Ammunition and supplies stored in compromised sheds were damaged, delaying operations. Engineers often had to rebuild, redirecting labor away from fortifications or logistics. Diaries from the 1st Cavalry Division note repeated maintenance on shelters, a task that became a cycle of labor-intensive patching rather than meaningful preparation for combat. The Korean War shows that structural decisions are not merely about convenience. They directly influence human endurance. A single sagging floorboard or leaking roof might not seem consequential, but over weeks and months it shapes readiness, morale, and survival. Old carpenters prioritized material selection and treatment. Historical carpenters understood that wood choice is as important as joinery. Hardwoods like oak or ash were selected for load-bearing elements, while softer woods were used for panels or, less critical components. Seasonal drying, curing, and basic chemical treatments, such as oil or tar, were applied to reduce moisture absorption. During the Korean War, engineers often bypassed these steps to expedite construction. Local timber, harvested quickly and sometimes still green, was prone to shrinkage and warping. Roofs sagged under snow and walls bowed under the stress of temperature shifts. Soldiers improvised shoring or improvised materials, but the underlying design flaw remained. The lesson is clear. Durability depends on the marriage of appropriate materials and the right construction techniques. Even minor adjustments could have made a significant difference. Several adjustments could have prevented the worst failures. Elevating floors slightly above ground level reduced moisture exposure. Simple overhangs and roof pitch adjustments minimized water penetration. Pre-treating critical beams with oil or tar slowed rot and fungal growth. Many of these measures were known to traditional carpenters, but were underutilized in wartime expediency. Field records from British and Commonwealth units note that posts treated with basic preservation methods lasted multiple seasons with minimal maintenance, while untreated structures deteriorated within months. These examples demonstrate that small, deliberate measures can dramatically affect both survival and operational efficiency. These lessons influenced post-war military engineering practices. After the war, militaries incorporated lessons about timber selection, joinery, and treatment into construction guidelines. Elevated flooring, moisture barriers, and careful joinery became standard in cold-weather manuals. Engineers learned that short-term expediency often carried hidden long-term costs. Similarly, disaster relief and civilian reconstruction projects in Korea and elsewhere adopted these lessons, showing that practical field experience informs both military and civilian engineering. The broader implications for survival and preparedness. Beyond military history, these lessons apply to anyone building in extreme or variable conditions. Survivalists, architects, and engineers must consider load distribution, material properties, and environmental exposure. The Korean War provides a clear historical example. Ignoring basic structural principles leads to repeated repair, wasted labor, and, honestly, compromised human safety. Understanding these failures also provides insight into human decision-making under stress. Commanders prioritize speed and immediate functionality, often at the expense of long-term resilience. Observing the consequences helps us appreciate the value of deliberate, informed construction decisions in both past and present contexts. Structural decisions reflect broader patterns of human endurance. History often emphasizes battles, tactics, and politics, but structural failures reveal another dimension: the mundane, technical decisions that quietly shape outcomes. Soldiers endured hardship not only from combat, but from the environments they were forced to inhabit. Their endurance depended on choices made by carpenters, engineers, and commanders. When those choices were informed by skill and knowledge, structures lasted and lives were spared. When they were neglected, the cost was immediate and cumulative. The Korean War reminds us that historical insight requires attention to detail beyond the battlefield. Timber, joinery, and treatment techniques mattered because they intersected with survival, efficiency, and morale. Observing these overlooked realities enriches our understanding of warfare, preparedness, and human ingenuity. Remembering the lessons of old carpenters matters today. Modern builders, survivalists, and engineers continue to make the same mistakes seen in Korea. Fasteners alone cannot replace thoughtful joinery. Untreated wood will warp and rot under environmental stress. Speed cannot substitute for understanding material properties. By studying historical cases, we gain a blueprint for both durability and human endurance. If you value understanding history in depth, not just through famous battles, but through practical lessons that shaped survival and strategy. Subscribe to History Vault. Share this video with others who want more than surface-level accounts and who recognize that the overlooked details of construction can reveal broader truths about warfare, human decision-making, and resilience. The lessons of old carpenters endure because they were grounded in observation, experience, and practicality, principles that remain relevant for anyone building, surviving, or studying the past.